Welcome to our MathLinks webinar, Dig into Intervention, a Fraction Array. In this session, we are going to explore some strategies for teaching fraction concepts. I'm Shelley Kriegler, one of the authors of MathLinks, and our presenter today is another MathLinks author, Mark Goldstein. We hope you will enjoy the session. Take it away, Mark.
Thanks, Shelley. Let's get started. Research tells us that students who don't have a good grasp of fractions need both conceptual understanding and skills fluency. In this session, we'll focus on the conceptual development piece using a fraction array to understand equivalence and ordering. Then we'll use the array as a way to help students eventually generalize these concepts so that this tool is no longer necessary. Visuals are great, but we can't rely on them forever. Here are some things learned from research to help students fill in the gaps. Number sense with whole numbers and fractions is important for students to be able to move forward in the middle grades and beyond. Many students are visual learners. Pictures and manipulatives are helpful. Have a plan. Be purposeful, methodical, and direct. Here are two common models for representing fractions. Area models tend to be very popular. Notice that all four of these pictures represent fourths. A unit is clearly defined as one whole square, and all parts have equal areas, but they aren't necessarily congruent. Common Core stresses linear models early on. A unit's clearly defined, and there's exactly one way to split the segment into four equal parts. The first part is 1/4 of that segment, and the tick mark represents the 1/4 point. Note that Common Core starts in grade 3 with unit fractions as building blocks. Since it's the most familiar fraction, it's always good to begin with halves. The little rectangle at the bottom is a place to write the fraction name. The extreme edges are clearly marked, in this case 0 halves and 2 halves. Doing this helps with the notation and language that go along with the conceptual development. I think saying 0 halves reminds us that what we call 0/2 is 0. But saying over 2, however, doesn't really mean anything. We may as well call it 2 under 0. Have you ever heard a student call the fraction 2 halves 2 twos? I think 2 twos is 4, don't you? 2 halves is clearly one whole. Here are two rectangular fraction strips. The top line is an area model because each of the four sections represents an equal part that is 1/4 of the total area. We're going to focus on the bottom one, a linear model. It acts more like a ruler. Let's start making our fraction strips, which will eventually lead to our fraction array. You'll need several strips for this activity. So here are some finished strips for halves, fourths, and eighths. Ask students to explain how they created each strip. Many will create fourths by folding their halves in half, and eighths by folding their fourths in half. Have them write and verbalize these relationships. Namely, 1/4 is half of 1/2, and 1/8 is half of 1/4. Not only is this good for making sense of fractions, it's a good connection to fraction multiplication. Even with just these three strips, there's plenty of questions we can ask. There are different names for 0 and different names for 1. There are many ways to write 1/2. What does it mean to be a unit fraction? And how can we compare them? Repeat the activity for other fractions. Here we have thirds, sixths, ninths, and twelfths. Ask students to share their partitioning strategies and some of the relationships they see. And of course, continue with questions about unit fractions, equivalence, and comparing fractions. Here's a completed fraction array chart, as if we made strips for halves, 3/12ths, and lined them all up. This is a great tool to do a lot of the comparing and ordering work with fractions we've been talking about. Now let's turn our attention to 5 fraction ordering strategies. We're going to use the array to make sense of each of these strategies. Our first strategy, we see some unit fractions circled, and here's one question we could ask. Creating more equal-sized parts from the whole makes them smaller. So clearly 1/5 is greater than 1/8. Eventually, students can generalize this relationship and move away from using the visual. A greater denominator makes for a smaller fraction. Our second strategy. Common numerators may sound strange and unfamiliar to some, but this terminology does appear in the Common Core standards, and it's very useful, and it's not very difficult. Since this is an extension of the unit fraction strategy, here's a generalizing question we might ask. We're looking at the same number of parts of different sizes. For example, if 1/8 is greater than 1/10, then it stands to reason that 3 of these eighths must be greater than 3 of these tenths. Our third strategy, the old standby, common denominators. Can we generalize a relationship here so that a model is not needed moving forward? Certainly, if we're looking at the same size parts, more of them are greater than fewer of them. Our fourth strategy. Benchmark is not a well-defined mathematical term, but we might think of a benchmark as a common or easily recognizable fraction. For some students, maybe half is the only benchmark fraction to them, but others with more experience may also include fractions like thirds or fourths. So, double 5 is greater than 8, or 5 is more than half of 8. Students can generalize this strategy, having the denominator or doubling the numerator, whatever works for them. Our fifth and final strategy, fractions close to 1. These take a little practice. Consider 7/8 and 4/5, which are both a bit less than 1. 7/8 has the lesser unit fraction missing, so it's the greater fraction. Let's ramp up the difficulty level with 8/11 and 14/17. Both of these fractions are 3 parts shy of a whole. Using what we know about common numerators, we can conclude that the smaller missing part is 3/17. So 14/17 must be the greater fraction. I hope you found these ideas around fraction concepts useful. To get the handouts for the blank fraction strips and the blank array chart, go to our website.
Thank you, Mark. That was great. The Center for Math and Teaching is the home for all MathLinks programs. These include comprehensive curriculum for grades 6 through 8, customized intervention and supplementary programs, and professional development. For more information about our programs, please visit our website at www.mathandteaching.org. We hope you found this session valuable. Please feel free to contact us anytime, and thanks for joining us. See you next time.